Hey class, here's the lesson for 6.2 radicals and rational exponents. First thing we're going to work on is this warm-up. Please compute the numbers first, so you should be the one doing this. You should not just wait for me to write down the values. Go ahead and complete this, and then we'll move on. You'll need to put in what you notice and what you wonder into our Canvas page. So these are the values. You might notice that the ones with the squares are always getting bigger. You may also notice that if you have negatives inside parentheses, they become positives, but if you forget to use parentheses, they stay as negatives. You'd also notice that the 1/2 and the square root are the exact same thing. They both give you 4. And a 1/2 is the same as square root, so 4 to the 1/2 power is the same as the square root of 4, which is just 2. Here are the learning targets. Make sure you write these down like normal before we move on. So today's examples of finding the nth roots are going to be talking about, we know if we go in one direction, like 2 to the third is 8, but now how do we go in the other direction? So we're going to be looking at a lot of things that look like this. We have the nth root of a value. This is called a radical because it uses that radical sign. And we'll use the nth root of a. So a being the thing that goes underneath the radical, and n being the power. So the power root of whatever we're talking about. One thing to remember is that if you have power to powers, you can multiply them through. So to get rid of a 1/2 is to square something. To get rid of a 1/3 is to cube it. To get rid of a 1/4 is to raise it to the 4th. This stuff down here in the bottom, definitely write this down because that's going to help us out a lot. 1/2 power is the same as a square root. The 1/3 power is the cube root. The 1/4 power is the 4th power root. So on and so forth as we continue on with these. This here also shows some other key ideas. You know, if our power root is odd, then things will often only have a real root. If our power root is even, then that a value is going to determine on a few things. So if the power root is even, so if we have an even root, and the a value is positive, so it's greater than 0, then it's going to have 2 real roots. If the root is even, but the a value is 0, then it's only going to have 1 root of 0. If the even root happens, but then there is a negative value, there's going to be no real roots. So here's an example of each one. So the first one would be like the 3rd root of 27. The next one would be like the 3rd root of 60, oh, not the 3rd root, we're talking even roots here. The 4th root of 64. Another one would be like the 4th root of 0 or the 4th root of -16. So again, this one here on the bottom would have no real roots. This one would have 1 real root, this would have 2 real roots, this one would also have 1 real root on top. So looking at roots, so when we talk about this, what we mean is we take that a value, we put that in the bottom of our power root. So we have the 3rd power root of -27, and this one over here we'd have the 4th power root of 16. Now again, you're going to have Desmos, and you can make use of Desmos, so when you pop these into Desmos, you'll quickly find that this one becomes -3, and this one becomes 2. There are some other examples here we'll want to make sure we can work through. Again, use Desmos, so you can pop then this value into Desmos. You might have to click around to find the nth root power, but that's okay. We want you to be able to find these things. For this one, it would become -2. For b, because we have the negative in front, we would have the negative value of 2 because the 3rd root of 8 is 2, but because it's a negative in front, this one also becomes -2. Notice that this one doesn't directly become -2, there's because of that negative value in front. 16 to the 1/4, that's the same thing as saying the fourth root of 16, which is simply equal to 2. 2 times 2 times 2 times 2 is 14. This next one, we have an even root, fourth power root of negative 16. This one has no real roots. And we went over why earlier in our lesson. Again, even power with a negative underneath the exponent does not have any real roots. Some concepts here you'll want to keep in note of. If you have anything raised to a power with a fraction, you're going to rearrange it so that way the denominator is the power root and the numerator is the value being squared on the outside. So notice how this one had 3 as the denominator, that becomes the power root, and 2 as the numerator, that becomes the general square on the outside. Rearranging these things can help you solve different types of problems. So looking at example 3, there's a couple different ways to solve A. One way to solve A is shown in your book. You can do the following. 16 to the 1/4 power raised to the third power. This works out because then you can have the fourth root of 16, get that, and then cube it. So we get the fourth root of 16 as 2, and we raise it to the second power. Additionally, though, what I think you would prefer to do is do the following. Right away, change this to the fourth root of 16 to the third power. And then go ahead and simplify that by putting it into your calculator. By plugging all of this into Desmos, you would get down to the same answer of 8, but you get it much faster. Again, use your calculating tools to help you out. So for B, how we could rearrange that one would be the third root of 27 raised to the fourth power. This would then become 3 to the fourth, which is just 81. Again, use your calculating tool to help you out. Here are some extra examples that would be good for you to work through and know how to do. Try them on your own first, use Desmos, and then get those values written underneath. Your answers are as follows, but again, you need to be learning how to put this into Desmos so you know how to solve for it. First one would be negative 5. The next one here. And as you work these through, this one would become 16. This one here would become 243, and the last one would become 64. Again, it's important to be able to rearrange and then use Desmos to calculate. We've seen a lot of keynotes. Make sure you guys go back and take these examples and write them down. Looking at some of the word problems, again, word problems, whenever you see things like this, if they start to introduce other values, they might be telling you exactly what to plug in. So like for this one, it says the radius of a sphere is given by this big equation, r equals the third root of 3 times the volume divided by 4 times pi, where the volume is the sphere, of V is the sphere, and then the radius of the ball is the nearest foot. Use 3.14 for pi. So notice how they gave you the volume of the sphere and they gave you the value for pi to use. So that's where we plug in both of our values here. Simplify everything on the inside of your equations first. Once you have a simplified fraction, or as simplified as possible, then go ahead and plug this into Desmos. Again, use a calculator. We live in a day and age where calculators exist. Let's make use of them. This means it's going to be roughly 3 feet. It was probably 3 point something something something, but it was closer to 3 feet, so we're just going to estimate because it said use it to the nearest foot. Same thing for our next one. Again, it gives us a lot of information, but we have to read through the problem one thing at a time. So it says to calculate annual inflation rates in decimal form, we need to look from the value of P to F over a period of n years. So n is the number of years, and you use the equation F and P, where you start with what it started with, the principal, to where it finalized. So here we're going to take f over p, so our final value was 235,000, our starting value was 200,000. We said over a period of 5 years, so it's raised to the 1/5 power. Simply divide those, get this decimal, raise it to the 1/5 power, subtract 1. Again, using a calculator. If you type this entire line into the calculator, you'll get this no problem. This shows that you have a 3% rate. One thing to remember is that to move a decimal place, you have to move that decimal place over twice, so that way you get the value of 3.278%, which, like we said, that's where they got their about 3.3. All right, you guys have homework. Good luck. If you need my help, just let me know.